So thank you so much, everybody, for coming to our webinar. What you've come to today is an explanation of how certain equipment can be used to reduce your costs of load banking. Of course, we know load banking of generators is very important to make sure they are healthy and that they will perform when called upon. And so this presentation, that will be a focus. We are going to spend a few minutes, most likely, just introducing ESL as a company and their full product line in the emergency power systems division. But we have Richard Traver today, and Richard, thank you so much for donating your time today. And I believe Richard's been with the company quite a while. And with that, I'm going to turn it over to Richard.
Thank you, Michael, and welcome everybody. Very much appreciate you taking the time to come on in and learn a little bit more about how we can assist you in providing solutions for backing up your permanent generator, and in some cases where you just want to connect a portable generator. So we will be talking about 4 basic product lines and how they relate to providing these efficient solutions. We have our manual transfer switches, which is our storm switch, our load bank testing and portable generator connection unit, our generator docking station, and also our power outlet boxes, which are also used for load bank testing. So we'll differentiate how all of these products fit in to helping to maintain your permanent generator for its most efficient use when it's required. As we get into this, a couple of things we want to keep in mind is how things are UL listed in the marketplace. Lots of products out there are listed as UL 50, and that really is just talking about the enclosure. So UL 50 says this enclosure meets a certain standard. Doesn't have anything to do about the assembly, doesn't say anything about how the thing functions, just the enclosure. We're going to talk a lot about UL 1008, which is the proper listing for a transfer switch, meaning a transfer switch that is transferring the source of power, not transferring between 2 panels, not transferring between 2 different circuits. It's about transfer of power. And in order to get UL 1008, there's a lot of testing you have to do, such as heat rise testing so the cams don't get too hot, your overcurrent protection, making sure that the construction is such that your contractor, when he goes to install it, has plenty of room for the size and number of cables that may be required in order to connect that unit. And that can be very important in keeping down your installation costs. It also has to meet water resistance specifications because most of these are going to go outdoors. So UL 1008 is going to be something you'll be referring to. Keep in mind that all of your automatic transfer switches that you specify are all listed as UL 1008 as transfer switches. So this is going to give you a seamless design whereby all the transfer switches in that emergency power design are going to be properly listed as UL 1008. UL 891 we used for our Outtap, which is going to relate back to load bank testing. So we'll talk about the difference in those 2 listings and why it's important, again, to have the proper listing for the application. And then we also do termination boxes. That's just cable in, cable out. Basically, just if you ever have a custom termination box you need, we can do that. Do we have any questions or anything about UL listings? Okay. Let's look at our standard product. So all the stuff we're going to talk about, our storm switch, our triple switch, they're all going to fit within this category. Again, properly listed for the application. Our standard units are galvanneal steel, powder coated, wrinkle gray. They're built to a NEMA 4 standard and labeled NEMA 3R due to these holes that are down here at the bottom, which allow the cables from the generator to connect to the transfer switch or docking station. So once you're connected, obviously you're not watertight. So when it's not in use, it pretty much meets NEMA 4 standard, but it's labeled NEMA 3R. Cams are Series 16, 400 amp, 600 volt rated cams. Number of manufacturers there you can see that provide those. They are all interchangeable. But keep in mind that there's still people out there that talk about connecting with lugs. And if somebody is going to do that, takes a certified electrician. They're not always available in an emergency. Also, it takes much longer to do, which means you're going to be without power longer. So if they want and are afraid that their cables are going to show up without the proper receptacles, not a problem. We can sell them a receptacle kit and they can put together the connections fairly quickly. The units will come either wall mounted or pad mounted. Depending on which type of unit it is, it's either 800 amps or 1600 amps determines when they become pad mounted. If you have a wall mounted application where you're not going to mount it to a wall, it's going to be remote. We can provide the optional leg kit. Those typically in those situations, a lot of times the contractor is building his own trestle because he's also going to mount a disconnect or a meter or something else, and we'll just fit on the same one. But in those instances where that's not going to happen, we can supply a leg kit. Your pad mounted units, they come standard with a side wireway to bottom feed. Since most pad mounted units, the conduit is going to come in the bottom. The unit still can be accessed for conduit on the back and the side and the top and other places, but the majority of them we found are bottom, so we just make that capability standard on the units. Any questions on the standard product? Okay. You also can get a number of options these are kind of the most commonly requested, but we do all kinds of other things as well. So if you need a surge suppressor or a voltage meter or something else, if it's not on this list, by all means, we typically can do it, but these are the most common. You have the phase rotation monitor. So when you hook up a portable generator, you know that it's in the same phase as your utility or your permanent generator. We have the utility indicator lights off there to the side, the little red light, so you can tell when the either utility power has been restored or the generator is on. There's the twist lock receptacle down there in the lower right-hand corner. That's so if you're going to pre-stage your portable generator, you can hook up battery chargers, heaters to the portable generator, other types of accessories that they may want to plug in while it's being staged. And this would be something where you know a weather say incident's going to come in, and you want to pre-stage the generator so that if you lose power, you can restore it very quickly. We can put terminal blocks inside the unit for connecting all kinds of remote signals. This is going to come into play with your load bank testing and other applications if you want to monitor SCADA and things like that. We can put strip heaters inside the unit, and they kind of serve a dual purpose. Down in the Southeast, a lot of units have heaters in them to control humidity inside the unit so you don't get water condensation. In colder climates, they're used so that the door doesn't freeze shut. So those are somewhat popular depending on your location. We can put shunt trips on the breakers to open them up with an automatic signal. Again, this is going to come into play when we talk about load bank testing and the importance of being able to provide shunt trips. The aux contacts also on the breakers, so you can monitor the position of the breakers and send certain information with certain breakers to remote locations. 304 and 316 stainless steel for the units. And keep in mind that when you have a riser drawing and you'd like to designate the enclosure to be stainless steel, the proper designation would be now NEMA 3RX. A lot of people in the past would call out for a NEMA 4X. And as we talked about previously, you really can't do that with most of the transfer switches and docking stations because you have holes in them in order to bring in the cables. So it was kind of confusing. So NEMA went back and provided the designation of NEMA 3RX for units that are going to be stainless steel. And then on certain units that are wall mounted, we can provide extended enclosures. What we do is extend the depth of the enclosure so that conduit can come up behind the cam locks. So on certain units, our triple switch and our Temp Tap, the bottom of the unit is populated with all of the cams. So if you want a bottom feed, we have to provide you some access. So we extend the enclosure and bring the cams up behind. Do we have any questions on the common options or other options you may be curious about? Okay. Again, we can do almost anything that that you may come up with. So as we're talking about permanent generators, not only is load bank testing and some of the requirements there important, there's the NEC 2017 703F code that talks about backing up permanent generators. So this code is written so that if a system is legally required single source of power and it becomes disabled for maintenance or repair, you must provide some means in order to back up that permanent generator with temporary power. So the question here is what's legally required? And most of the time you would think about a hospital. They're legally required to have generators. Now, they don't typically fall under this code because most hospitals will have multiple generators, so they have backup to the backup. However, there are a lot of medical facilities, smaller hospitals, clinics, rehab facilities, dialysis, other types of medical facilities that only have a single source permanent generator. So they would be legally required to have some sort of backup for that permanent generator. What is legally required also is determined by the authority having jurisdiction or by the state, the county, or the city, or the district that may have codes that say something, some facility is legally required to have a permanent generator. So that would be something like a shelter in place. So we do a lot of gymnasiums at high schools because in certain areas they're designated as shelter in place. They have kitchens and other facilities there. And so they have to have a permanent generator, and that generator has to be backed up. A lot of states now, assisted living facilities are legally required to have a source of permanent backup power. So data centers, police stations, fire stations, there are a lot of legally required systems out there that you'll have to, know about as you're designing things, and they need to be backed up. Doesn't need, sometimes, again, depending on the code, it may not be the whole facility has to be backed up, just life safety or critical infrastructure systems, but they do need to have backup power. Whatever you choose to do, you can't modify the permanent wiring system. It has to be something that you can tap into what's already there. Again, since you have now two power sources, they have to be mechanically or electrically interlocked to prevent both systems from being on at the same time. And you have to be able to tell the facility that the permanent generator, the primary source of backup power, is now offline. So you have to be able to send a signal to a remote annunciator saying that the permanent power is offline and we are now on portable or some other backup power if we were to use utility power. So all of these requirements are standard in our triple switch when it's used in conjunction with an ATS. In addition, with our storm switch, if we add the aux contacts to it, it also then becomes compliant with NEC 2017, and we'll talk about that here in a second. So that's pretty much an overview of that. Do we have any questions on NEC 2017? Okay, keep in mind that a lot of the authorities having jurisdiction are expanding on this requirement in the sense that a lot of them will come back to the designers or the owners and ask if a building is going to be occupied by people. If there are a lot of people in this building, we see this more and more with certain office buildings. They'll require that building meet the 703F part of the code, even though they may not be a legally required building at the time. Because it's occupied and it's got a permanent generator, they'll require that the design include some sort of backup. So just a heads up on that. So our storm switch, basically it's our manual transfer switch. The nice thing about it is it's mechanically interlocked, which means you don't have to design in Kirklock schemes. It's all self-contained. It's got the cams, got everything in it. Makes your job very easy when you have to design in something where just portable power. They don't need power instantaneously, but they want to be able to continue to operate after a couple of hours. And this now becomes a means to do that very economically and very user-friendly. Yeah, we are UL 1008 listed up to 3,000 amps. So all of our units are UL 1008 listed up to 3,000 amps. If you need higher amperages, we certainly can do it. And those are NRTL field labeled by either ETL or Intertech. So we certainly can go above 3,000 amps. One of the nice things that your end users are going to appreciate is that all the operating instructions are provided on the door dead front. So on the wall mount units, it's right on the door. They can walk up to it, see exactly how they need to operate the system to hook up their portable generator. You don't need a certified electrician, and you don't need to have one special person if you don't want to operate the system. On the pad mounted units, when you open the main door, then the operating instructions are right there in front of all the breakers and everything. So very, very user friendly. And then again, as we mentioned, if we add the aux contact on each of the breakers, we then meet NEC 2017. So where you would use the storm switch to back up a permanent generator is where you've got a permanent load bank, or they're not load banking with a portable load bank, except into the permanent generator itself. Now that's cumbersome and it's very expensive, but a lot of people still do it sort of the old-fashioned way, and all they want to do is meet the 2017 code. So a storm switch will allow you to back up your permanent generator, and now you have a safe means to interlock the permanent and portable generator so that only one of them can be on at a time. Also, from a design standpoint, you see the wall-mounted units, they come SUSE rated standard. So if you're under 800 amps or below, the unit's going to come SUSE rated, so you don't have to design in a separate disconnect if you're using this to switch between utility and a portable generator. The utility breaker on this unit can be the service disconnect. So again, saves you a little bit of money, saves you a little bit of installation costs, and makes it very efficient. On the pad mounted units, the service entrance rated is an option. It adds a little bit of cost to the unit, and we don't want to charge people for something that they don't need, but these can come service entrance rated. We just have to know if you're going to use it that way. So your storm switch applications, again, switching between your permanent and portable generators, or anytime you need to bring in a portable generator to back up your facility, and you don't have to have power instantaneously. So now let's talk about the triple switch. And as you can see, the triple switch provides a means where you can switch between your portable generator, your permanent generator, and a load bank. So it provides all the functionality that you need to accomplish both of these functions, and provides then a quick connect for all of that, and makes it very, very efficient, very, very cost effective. 70 to 3,000 amps are the range of these units. Again, that means they're UL 1008 listed up to 3,000 amps. That's very unique in the marketplace. Since these are dual purpose, they don't technically fall under UL 1008, because UL 1008 talks about only inlet power, talks about only having male cams, and these units have both male and female cams. So getting them UL 1008 listed was very cumbersome. We had to go to UL and get all kinds of extra testing done, waivers, everything else, in order to have these UL 1008 listed. But it now provides you with a design, again, where you have a UL 1008 listed transfer switch connected through a UL 1008 listed ATS, and you're providing your clients with a nice, seamless type of design. So that is unique in the marketplace. You'll see a lot of other different variations that talk about how they're listed to the standard, but there really is no UL 1008 standard with both male and female cams in there. So here is how the triple switch is set up. You can see how all of the connections come together. You can see here that the load bank has a shunt trip on it. This is your load bank connection. Then you have your ATS to permanent generator connection and your portable generator to ATS connection. Those two are mechanically interlocked, so only one of them can be on at a time. And then you have an aux contact on this middle breaker, because when that is shut off or opened, that means the permanent generator cannot provide power to the ATS. So that's where we signal that the permanent generator is now offline. We're sending that remote annunciator signal back to the facility to meet NEC 703F. And then you have your cam locks, your male cam locks for your portable generator, for if this is offline and you were to lose your utility power, now you can provide power directly to the facility with the portable generator, which on these application now, the triple switch also comes with the terminal block for the remote auto stop and start signal for the portable generator. So it now acts just like the permanent generator. So we're going to show this video here, and hopefully it will come through. Whoops.
Those that service their emergency and standby power systems are aware of NEC Article 708 and NFPA 110 regulations to regularly test permanent generators and automatic transfer switches. These regulations are in place to ensure that when utility power goes down, the backup equipment will effectively support the facility's electrical requirements. As of 2017, NFPA's National Electrical Code Handbook also includes provision 700.3F, mandating legally required systems be able to connect a temporary source of power for emergency systems that rely on a single alternate source of power, which will be disabled for maintenance or repairs without modification of the permanent system wiring. Well, when used in conjunction with an ATS, the triple switch has got you covered. ESL's UL 1008 listed triple switch provides operating functions during various conditions. When first installed, the permanent generator is hardwired into ESL's triple switch, and the output from the triple switch is hardwired to the facility ATS. Under normal conditions, the center breaker is turned on, connecting the permanent generator to the facility ATS. Utility power flows normally through the meter, ATS, and distribution panel into the facility. During a utility power outage, a startup signal is sent from the ATS to the permanent generator. Once the ATS detects proper voltage, frequency, and phase sequence, the ATS switches over and power is then provided by the permanent generator. When load bank testing of the permanent generator is required, under normal conditions, a load bank tester is connected to the load bank connection point in the triple switch. The center breaker is left on. Next, the left-hand breaker is turned on. This connects the permanent generator to the load bank connection and also leaving it connected to the ATS. The permanent generator can be started and the load bank testing can be done. When load bank testing is in progress, both the left side load bank breaker and center ATS breaker are on. If utility power is lost during the load bank test, a signal from the ATS is sent to the shunt trip on the left side load bank breaker to open the breaker. Since the center breaker is on, The power from the generator is immediately redirected through the center ATS breaker to the facility, making the switching time compliant with NEC 700.3F5. Anytime the permanent generator is disconnected from the emergency system, such as for maintenance or repairs, the annunciator circuit is activated. A separate portable or secondary permanent generator can be connected to the portable generator connection point during a utility power outage and by turning on the right-hand breaker. Only after the interlocked center breaker is turned off, the portable generator is then connected to the emergency system, providing emergency power to the facility. ESL solution simplifies the traditional connection-disconnection process for legally required systems. The triple switch combines generator quick connects for redundant backup power with dry contacts provided for annunciator circuit at a much lower cost, smaller footprint, and can virtually eliminate wiring mistakes. ESL's three-way manual transfer switch is UL 1008 listed up to 3,000 amps and voltage ratings up to 600. Additional triple switch resources, such as specifications, spec sheets, and case studies, can also be found at eslpwr.com/emergency-power.
So here's a panel layout that you can see, again, showing that you know, under normal operations, during normal operations, when you lose utility power, you're going to automatically feed right to your facility. When you're doing a load bank test, and what happens if you lose utility power during a load bank test, and then hooking up your portable generator. Are there any questions about the functionality of the triple switch? It's a unique product, and but what it does is, you know, it allows you to provide solutions without having to design in a lot of extra breakers, a lot of Kirk locks, and it's really a drop-in solution, especially as you're asked by your clients to retrofit existing generators. They want to meet 2017 703F, or they want to start load bank testing their permanent generators because they've had issues in the past. The triple switch provides a very user-friendly, very unique drop-in solution for you to provide them. And so here's a, you know, sort of a typical drawing. Triple switch is usually put somewhere close to the permanent generator, but you know, it can be any distance away. It's just how far do you want to run your conduit, sometimes I'll put it a little closer to the building versus closer to the permanent generator. But you can see this is a drop-in solution. So if this were an existing building, for instance, you wouldn't have to go back in and figure out, okay, where do I put a breaker to make sure this is interlocked? Where do I put a breaker to make sure that's interlocked? Does the generator have breakers? Where do I put the Kirk keys or the Kirk locks? You can just drop this in and tap into the existing conduit, and you're pretty much good to go. So from a design standpoint, very convenient. So your triple switch is going to be used pretty much anywhere where you have a permanent diesel generator. We have done some triple switches with natural gas generators. They typically don't need to be load banked quite as efficiently or often as a diesel generator. The load banking, you know, is necessary with a diesel generator because of the phenomenon of wet stacking, because the diesel fuel doesn't burn clean, doesn't get hot enough because it's never run under a load, whereas natural gas is very clean burning, so the generators don't have a tendency to wet stack and get sort of hardening of the arteries. But a lot of the generator providers do suggest that even natural gas generators be load banked under a load at least once a year, just to test the full functionality of the generator. So we do a number of natural gas ones as well. So any place that you have a permanent generator, a triple switch should be considered to provide the most complete solution to making sure you can properly maintain that generator. And as you're talking to your clients, you have to make them, kind of realize they're investing a lot of money in this permanent backup generator system with the generator, the ATS, the controls, the fuel tank, all of that. They should have a way to properly maintain it and back it up. And this only adds a very small percentage to the cost of not only the emergency power system, but also to the total facility. So it's not putting typically a lot of stress on any budget to provide them with some reliability in the future. Then the Temp Tap is a docking station where your switchgear, ATS, MTS already exists, and you're just looking for a means to provide a quick connect solution for the client. So a Temp Tap is used for generator docking stations. It has male cams signifying inlet power. They come in 400 amp increments. They're UL 1008 listed up to 3,200 amps. We've built them now up to 5,000 amps. Those above 3,200 amps are NRTL labeled. And you just need some sort of upstream disconnect, whether it's a manual transfer switch, an ATS, switch gear, some way to make sure this portable generator isn't on at the same time as your other source, whether it be utility or another generator or UPS system, whatever it might be. But it's just a docking station, no breakers, although you can get this with a breaker in it and Kirk lock if necessary. So again, any place where you need to have the switchgear, whatever, inside the building, and you're looking to have it outside the building, keep in mind UL 1008 is important in these kinds of units. There are a lot of them out there that, again, are just UL 50 listed, which means the enclosure is, but these things can get extremely warm when you start getting up into the bigger amperages, and UL 1008 means that these are designed, as you can see with all this venting, so that these cams cannot get higher than 24 degrees above ambient. So part of UL testing is you have to make sure that if somebody comes in to disconnect from these cams, that they're not so hot that they could potentially burn themselves. And we have seen units where that has occurred. So being UL 1008 listed, even for something as simple as a enclosure with cams in it, is important, we think, in your design. The Outtap is then the opposite of a Temp Tap in that it is now outlet power signified with female cams. So somebody can open the enclosure, look at the cams, and know the functionality of that unit. That's why the codes are written that way, so people know whether power is coming out of that unit or power is going into that unit. Again, like the Temp Tap, you can get these with a breaker. They're used quite extensively where you want to power remote devices. A lot of places down there in the Southeast bring in portable chillers in the summertime. And rather than having to bring in a portable generator with it or a chiller with a generator, they can now use the existing facility power, and all they have to do is quick connect in and they're good to go. Sometimes they use them for exterior lighting. Sometimes they use them when they're going to do a renovation or expansion and they don't want to bring in a lot of portable generators. We've installed a number of these on some distribution facilities and other types of facilities where they're going to start a major renovation, and they just want to be able to quick connect in certain equipment. And then finally, this can be used for connection of a portable load bank for testing your permanent generator. So as I mentioned earlier, we've had a lot of occasion in the past where we've provided temp taps or storm switches to back up the permanent generator. And now the client's coming back and saying, okay, I've had some issues. I need to start load banking my permanent generator. And I don't want to have to do it the old fashioned way and open up the generator and get into a circuit breaker and connect and disconnect a whole bunch of cables and all of that. So the Outtap, typically we do it with a breaker for load bank testing, but not always. Can now be used to bring in your portable load bank and quick connect it into your permanent generator. So a very efficient, user-friendly way to assist your clients where they already have a means to back up the generator. Now they just need to load bank it. We can put a shunt trip if you get it with a breaker. We can put a shunt trip on this breaker so that if you lose power during a load bank test, it'll open up that breaker and power can be provided to the facility. So that's it. Questions? All right. Well, hopefully this helps to allow you to make some very cost-effective, very efficient designs. We're seeing a lot more instances where emergency power is now being required on various types of facilities, and people are going back and reevaluating their backup to their permanent generators and whether or not they should be load banking them. I think if you talk to your generator providers, they will tell you that the newer, higher tier, more efficient generators are more susceptible to wet stacking, and therefore really having load bank capabilities is becoming more and more important as you design these systems in, and these higher efficiency generators are needed. So please contact your L3 person. They're very proficient in all of these systems and can help you, with answering any questions or getting you drawings. If you need specific drawings for a project, we're happy to provide those that will have a specific item number if you've got certain options and features and everything that you want to include with your design. We'll make a site-specific drawing that then can become the specification for that project. And it will pretty much already be designed before the project goes to bid. So L3 can help you get those drawings all put together. That's it for me.
Thanks for that. That was great. If anybody has any questions, they can put it in the chat box, or you can just unmute your speaker and ask him. Rick, I've never seen it where you didn't have at least one question.
Yeah. Richard?
Yes.
Question I have got, with the COVID-19 issues right now, are we seeing any delays in some of the manufacturing or getting some of the products, or are we pretty much on track with the supply?
It's a great question. Right now, we're running at pretty normal capacities. We are having a slight issue with certain size breakers. Most of the larger amperage breakers that are made to order by a Schneider. So all of our units use square D, Schneider square D breakers. On some of the larger amperages that they make to order, the lead times have been increased by a couple of weeks, sometimes even as far as a month. So we are being very sensitive when we quote things, where in the past we might have quoted something 8 to 10 weeks. We may be quoting them 10 to 12 or even 12 to 14 now. And it's really mostly to do with that. The other major components, everybody seems to be providing pretty much to their standard delivery times. There was an issue with the bus bar that's used in the pad-mounted units for about a month, and we're just coming out of that now, so we don't anticipate that being an issue anymore. But that's really the only place where we've seen any effect so far in lead times or anything is on a few of the larger pad mounted.
Thank you for that.
I also, I should mention that with any one of our units, we can provide extra breakers in enclosures mounted to our units. We've come across a number